34, so I got 25 minutes.
Thank you for watching our 24-hour-a-day live stream here at Explore Scientific, where we show you all the programs that we run live in front of a live audience. Programs like Global Star Party, On the Wing for birders, First Light Chronicles for beginners, and Focus on Astrophotography for astrophotographers. We bring in astronomers and explorers from around the world to answer your questions live. But there's so much cool information there that we decide to package it all together and run it 24 hours a day. We're also on Amazon Live, where we do deep dives into our products and our gear, all designed to help you have a greater exploration experience. There's so much important information as we share the education, the experience, answering questions from the audience, that kind of thing. So tune in, and thanks for watching.
As we get into episode 43, this is the crazy busy time of the year for me as a working professor of STEM education. We are entering the last 2 weeks of the semester at my university, at the University of Arkansas, and that means all the end of semester projects are coming in. And last week somebody said, well, how much stuff are you talking about when you're talking about grading, Doc? And so I went and photographed my 14-inch stack of materials, and somebody says, well, how much is that really? So I threw it on the bathroom scale, 17.4 pounds of paper to read through and grade. And that was just last week. I've got another stack coming in this week. But then, thankfully, the semester will be wrapping up the second week of May here. And I will have more time to focus on fun things like astronomy and science education activities that are outside the classroom. So we're going to have some opening comments today. We try to do this every week. We don't always get to it. But part of my prep for this show, friends, is I spend a fair amount of time. I have a lot of news feeds that come in from NASA, from ESA, from JAXA, and different space agencies, and I'm looking at what they're doing. One of the fun things I saw, and how long have I been a space science fan? For more than half a century, since the Apollo era. And I just learned, I was today years old when I learned that there is a website that will show you what the Hubble Space Telescope is looking at live. And we have our show notes for today, which Scott is always kind enough to download, make available as a download for you. And there's a website called spacetelescopelive.org/latest. And when you log on to this website, it shows you what the Hubble telescope is seeing right now, which is, to me, so exciting. Hubble has been up there for more than 30 years, and we're looking at what's coming down from one of the world's first space telescopes right now. So it's a very dynamic and interesting thing, and you can see what Hubble is looking at in a little bit about it, which is a fun thing. And there's also a Space Telescope Live Twitter account. So if you all are Twitter users, that's another fun science adventure for you.
Right now, Hubble is acquiring a new target.
Yeah, every once in a while when you look up, Hubble will be slewing around to a new target, and so there will be no feed at that point. But it's fun. I've just become addicted to popping in and out. What's Hubble looking at right now? And of course, time on the Hubble telescope is extraordinarily precious. The process for getting in to get Hubble Space Telescope time, that's no small deal, friends. You have to submit a proposal, defend it, committees critique it, and other space scientists decide, are you worthy? Because there's only one Hubble, and there's lots of people who want to use it. The other thing that I was just stunned, and every once in a while I come across science news, and I'm just amazed. Some of you may be fans of the Star Trek universe in the various programs, and I forget which program it was, but they had the holographic doctor. He had no name. He was an emergency holographic program, and he would come online and said, what's your medical emergency? And the idea is if the regular doctor got sick or injured, that the holographic doctor could go ahead and tell you what to do. Well, guess what? We are living in the future, and NASA beamed a doctor up to the ISS as a three-dimensional hologram that people could see and view and interact with in real time. I am so stunned by this. And the Microsoft Holovision camera system that they used for Xbox was part of this research. And they have a projector on the ISS, and they were actually able to beam a doctor as a hologram live into the ISS, which makes me think the next rover that goes up, heck yeah, I mean, how much would you pay, Scott, to be holographically beamed to Mars and to be able to look out and swivel around and see what you could see from the rover?
Probably a lot.
Probably
quite a bit. Yeah.
Oh yeah, and I don't think I could. Maybe Scott could afford it, y'all. I don't think I could, but maybe Explorer could afford to buy me 2 minutes on Mars. But oh my gosh, I realized that at my age, I am never flying to Mars. I dreamed of it as a kid. Oh my gosh, I went through. Oh yeah,
holographed up there, right?
Yeah, to be able to go up as a holograph on the moon, on the ISS. I'm going to get 2 minutes on the ISS just to look out the window as a hologram, and somebody could take a picture of me as a hologram up there looking out the window. I would pay some serious coin for that. And you might say,
Yeah.
that's a frivolous use of technology in the international. No, it's not. Oh my gosh.
Not at all. In fact, it's a great use of technology in the internet.
When we make it real for people, part of what the astronauts in the Apollo program did for folks on Earth is they made space travel real to them. They were more than astronauts. They were more than scientists. They were fun, engaged fellas having fun doing science on the moon, and to some extent, we all went with them.
Sure.
That one of the last pictures of the moon, and I think it's Dave Scott, and he's jumping up and saluting, and his co-commander is taking the picture there, and just wow. Wow.
Live from the moon. I remember Apollo 11, they just had the headline down on the bottom.
Live from the moon.
Live from the moon. We're like, what?
Which we haven't done since 1972. Oh my gosh, it's 50 years since we've been to the moon with people, which is a shame.
Can you imagine what the video is going to be like, though? The video coming back from the moon will be crisp, clear, 4K,
oh yes,
8K or whatever.
Oh my gosh, the people, I remember teaching high school and showing some of these Apollo videos to students, and they said, "Are you sure it's real? It's so blurry." I'm like, you guys know this is like 1960s TV technology. Yeah, it was quite low res.
Yes.
Yeah, absolutely. So, Scott, one of the other things we've talked about recently is we chatted about the solar tsunami. And we've had the sun is in a very active phase. We've had a lot of aurora, and people as south as the northern United States have been able to see some aurora in recent weeks. Well, we talked about this idea. Would the solar tsunami destroy our modern technological civilization? And it's interesting. The car website Hemmings, which is a car enthusiast website, Scott, they did some research, and they looked up and they did some research on, could your car survive an EMP? And they actually went to a facility and they took some relatively new cars from, I think they were surveying cars from about 2000 to 2010, some as old as 1990. And they were trying to decide, would older cars do a better job surviving one of these solar catastrophes? And it was interesting. What they found is something I realized, I kind of slapped my forehead. I should have known that. What they found was that most cars do just fine surviving a solar catastrophe. Because when we have this geomagnetic storm, what's happening is the magnetic field is waving. And it induces current. And we've all heard about the Carrington event, 1859. And this huge solar storm, auroras all the way down to Cuba. And they were saying that, oh, telegraph wires, they were having enough electricity to run the telegraph without batteries. The sparking caused some telegraph stations to start on fire. And they said, oh, well, this thing could be terrible. And in 1989, I believe it was, they had a very large solar storm that blacked out a large section of Canada. And what happened again? This waving magnetic field induces a current in a wire. However, it's not just the strength and fluctuation of this magnetic field that does this, Scott. What we've really got here, friends, it's also the length of the wire. If you were ever the kind of kid who took things apart, I did.
Yeah.
And Scott, did you ever take apart an electric motor?
I took apart everything.
Oh, okay. So
the toy that I got for Christmas, it was apart. You know,
exactly.
I had to see the motor, I had to see how it worked.
My mother, God bless her, used to tell the story that as a 6-year-old, I took apart her very expensive Electrolux vacuum cleaner. And she called my uncle, oh my God, Danny's taking apart my vacuum cleaner. And you have to come over here. By the time my uncle got over, I was afraid I was going to get in trouble. I reassembled it. And my mother said, don't touch it. And he said, well, and so he used his foot and turned it on, and it worked. Well, if you were a kid and you took apart an electric motor, what you may have found was that in the interior of the motor, what we call the armature, it's layers and layers and layers of wire. And what we don't realize is it's one long string of wire, many, 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 many meters of wire to make a little tiny electric motor. It is this length of wire that makes it possible for the magnetic field inside the motor and the alternating current to generate rotary motion. When we're talking about telegraph systems in 1869, we're talking about hundreds, thousands of miles of wire. When we're talking about the Canadian blackout, we're talking about generating systems which were not prevented from getting overloads. If you've got a surge suppressor on your computer at home, friends, as you're watching us, you've got technology that would stop an electromagnetic pulse or a geomagnetic storm from damaging your equipment. If you unplug your computer system, because we have warnings for geomagnetic storms. We get warnings of up to a couple of days. If you've got your computers and your televisions and your sensitive electronics unplugged, chances are they're not going to have a problem. When Hemmings tested cars, and they did, the United States government did a test called Starfish in the 1950s. They deliberately exploded a nuclear bomb in the upper atmosphere to create an EMP, and it blacked out radio transmissions across Hawaii for days, for a couple of days. And this was about, I believe it was 5 kilovolts per meter. They tested cars up to 30 kilovolts per meter, much higher than most geomagnetic storms. And they found that most cars had no effect at all. The wiring is so short in a car that it didn't really burn anything out. Now, some cars, about 20...
Let me ask you a question, Daniel.
Sure.
This is before cars had computers in them, okay? So
they were cars with computers in them, and some of them with dashboard electronics like GPS and navigation systems.
Okay.
And they found that sometimes some of the cars had malfunctions in the dashboard electronics, but in all but I think one case, when they shut the car off and restarted it, it rebooted the electronics and there was very little in the way of lasting damage. No cars were shut down while running because they tried this test with the cars off and the cars on. With the cars off, they didn't find any damage in any of them. With the cars on, some of the cars had glitches, like lights would blink or check engine light would come on. The GPS wouldn't work, but they turned the car off and on again. In all but one case from all the cars they tested, they had no permanent damage. They had some nuisance damage where they might have to replace, a relay or something else like that. But in no case did they have a system where the car was stopped. You see this like movies like The Day After, where all the cars come to a grinding halt on the freeway because the nuclear blast has gone off. Not happening, y'all. Not happening. The cars were not stopped dead in their tracks. None of them were stopped dead. And so this gives me hope that maybe civilization can survive the next tsunami. The other thing is that basically since the 1950s, the military has worked at hardening their electronics. And because of interference with ever more powerful LiDAR, radar, and wireless communications, most auto manufacturers harden the electronics in their cars just because we use so much. We have cell phones and everything, friends. We use so much.
Views, you want to observe the stars, you want to hang out with astronomers, but if you want to see amazing Milky Way views, you want to observe the stars, you want to hang out with astronomers, but you love art and you love music, you're going to want to come to the Arizona Dark Sky Star Party, September 21st to the 25th at Oracle State Park in Oracle, Arizona. It'll be an amazing event, and I know you're going to love it.
We got a countdown. 3, 2, 1. We started talking. Oh, dad gummit. Something's wrong. He started flicking buttons and clicking switches and chasing mice, and all of a sudden we were live, and we knew it.
Run. It'd be interesting.
He's pretty quick.
Oh, well, yeah.
Pretty quick. So anyway, I have Tyler on as a special guest, which he's very special, and he's a guest. And you know, I was wondering, and he and I literally have never talked about this before. So
we actually haven't.
I don't know how this came about. I started, I've talked to one person how they got started. I'm going to carry this theme a little bit more. Mm-hmm. Tyler started doing astrophotography and didn't know a constellation name, a star name. You could look up in the sky. He could tell you it was the moon. And that was about it by looking.
Orion was.
By Orion, but boy, there wasn't much. But last night he was saying, we were talking and he was testing something, and he was like, oh, there's Altair, and I was like, oh.
There's Vega, Altair, Arcturus.
Arcturus.
Yeah,
and it was like, how about that? He's getting some constellations. And that got me thinking last night, how did Tyler get started in astrophotography and without any astronomy background? We're going to talk about that. So, Osmosis 007.
Ooh, that's a good name.
Yes, it is. Well, I'm still new to the hobby. Got my first telescope since the 90s for Christmas this year. I honestly like to focus on eyepieces. I have the First Light Mac 127. Yep. Okay.
You're talking about some of the live stuff.
Oh, talking about some of the live stuff? Yeah. So we've been having a live stream running. We're getting ready to broadcast 24/7 on a multi-platform channel. We have a special device that costs about It's cost about $10. Very, very affordable and inexpensive. Maybe a little bit more than that. A little bit more. So, so are those coming from the previous show?
No, those were, but these are not. Sorry, we're reading the comments. But anyway, back to the topic that we're mainly looking at is you were wanting to know.
Yeah, back to the topic at hand. How did you get started, Tyler?
Well, the funny thing is I didn't start out in astrophotography first.
Okay.
I basically did because I just skipped visual altogether.
Hey, Tyler.
Yep.
Look at the camera.
That thing? Yeah. But I like looking at you.
That's painful to think about.
Anyway, my kid had a birthday. How old was he? I think he was 7.
One of your kids.
One of my kids.
You have 2 kids. There we go.
And he was wanting to get a telescope. He's always interested in the science stuff. We ended up getting can I say the other one?
Sure.
It was a Celestron alt-azimuth. It was a combo kit. It was great for beginners. That's about it. Pain to use. It was a real utter pain to use.
But the point is, it got you started.
It got me started. Used that for a couple of months. He never picked it up, never touched it, just when I got it out of the box. It was the only time he messed with it. I was like, well, I'll tinker with it. I want to mess with it. I've always been interested in space, never had the funds or the resources to do it. So I'm better than I was when I was a child. So we got that, started using it, and first thing we looked at was planets. We saw Jupiter.
Mm-hmm.
This scope did not come with a red dot finder.
What did it come with? Just a pipe straw finder scope? Ooh.
Yeah, it was a 6x30 straight through.
Ooh.
Very hard to
upside down and backwards.
Very hard to align.
So if you want to move up, you have to move down in the eyepiece. If you want to move left, you have to move right.
It was a challenging one, especially when
what was it, an 80 millimeter telescope?
That was a 70.
70.
Yeah.
Okay. 500 millimeter refractor, something like that.
It was a 600.
Yeah.
So it may have
long,
been
slow.
It was long too.
Yeah.
The thing was long.
Yeah.
So we looked at the planets. They were great. He wasn't interested, but I'm like, holy crap, I can actually see a planet. This is pretty cool. I can see a planet. Because everybody looks up, it's like, oh, it looks like a star. But planets look like stars, but they're not stars.
When you put them in a telescope, they're round.
They're round.
They're not just bright pinpoints.
Exactly. I mean, that's why Antares is called
not Mars.
Not Mars. That is the utter word or the definition of Antares is not Mars. Because he told me that. And I always found it was humorous.
Because it looks like Mars.
It looks like Mars because it's a bright red star.
Right.
And people always got it confused when Mars would, because the funny thing is Mars would actually go with it or follow the ecliptic plane and come alongside with it, and everybody got it confused.
One was a wanderer,
a
planet, and the other one was a star that didn't wander, and it was not Mars.
It was, so Antares.
Not Aries.
Yeah, so it was funny. So then I started looking at constellations. Granted, didn't know a diddly thing about it, and this was before I even knew Explore Scientific was here.
So this is how many years ago?
We'll say 5+ years.
Okay, all right.
So 5+ years. I didn't know Explore Scientific existed because I just literally went on Amazon, bought this thing, and done. Okay, what is the title? Okay, that's the last one.
Yeah,
that was one that was previous.
Okay, was it?
Yeah.
Okay, all right.
So I moved. He gave up an interest. He didn't want to do it anymore. So I was continuing to tinker with it, but it did come with a smartphone adapter.
Mm-hmm.
And so I put my phone on it, and I went out to the front yard, and I pointed it due east. And during that time, it was beginning of winter, so I knew Orion was coming up because I've always had a fascination with an Orion. I could pick him out faster than anything because I knew where he was.
It's very obvious. Once you learn that constellation, there's nothing else up there like it.
Exactly. So I literally took my phone, slapped it on the suction cups with a 25 millimeter eyepiece. Granted, this is with an alt-azimuth. Very terrible. But it worked. I got a fuzzy outside core image of Orion.
And you were excited.
I was giddy as a kid.
We should have gotten that picture because we know we're going to talk about this.
I think my mom still has that picture.
You need to get that picture and
I think my mom still has that picture.
Because you were just happy to get
that was the first person I sent it to.
Something.
Yeah, I got something. I got a little nebulae, and it was with the phone. So Mike Wiesner is right. You can get a whole lot of stuff with the phone.
Oh yeah, if you work it right, you know what you're doing.
So and that literally drove me into a sinkhole, and I'm still sinking.
So then what'd you do? What was the journey like after that?
The journey, I still wanted to do visual because I went on cloudy nights like everybody does and just try to soak up information as much as you can. And trust me, there is
Whoa, how'd you find cloudy nights? See, you had no background. You didn't know what cloudy nights was.
Google.
So what'd you Google?
Telescope information.
And here was this forum.
There was a lot of forums, but cloudy nights was the first one that popped up, which I'm still surprised that Explore Scientific couldn't pop up at that time. So I went to Cloudy Nights forum, created an account, and just read information. Just read. Created some posts saying name is blah blah blah. I'm new to the thing. Wrote some good books.
You let your ignorance hang out.
Pretty much.
Yeah,
it's okay. I'm very ignorant sometimes.
Well, we all are on subjects we don't know anything about.
I asked what's some good books to read because I think that's the main staple. Is if you're wanting to get into this hobby, get some. I would recommend at least 2 or 3 good books. Left Turn at Orion. That's one. I'm trying to think of another one. Oh my God. Well, I would recommend that one beginning.
Yeah.
Would be Left Turn at Orion. That will give you the basic concept of how a telescope works, constellations, and they have the constellation movement. I can't think of the word. They have maps. They have the constellation maps.
Yeah. Osmosis 007 said same thing.
Yeah.
Yeah. Get a planisphere.
The planet. See, I didn't even know about planispheres.
Okay.
Until eventually I found Explore Scientific, got hooked up with Mike Hatch. Mike Hatch helped me along that way. Picked up a mentor who I still talk to about visually. He says you need to learn the sky first.
Mm-hmm.
Need to learn the sky first because if you're using a manual mount and you don't know what you're looking at, you're going to be lost. You won't know where you're at.
Who was that?
His name is Joe Agassani.
I thought you were going to say Piscopo.
No. Do
you know who Joe Piscopo is?
No.
Okay.
Tell me later.
Did he die?
I think so.
Yeah.
Saturday Night Live.
Oh.
Yeah. Aw. Okay.
Anyway, Joe told me to learn the sky, and he also sent me a upgraded telescope because I've upgraded my mount to a tracking mount. It was a Celestron AVX. Started out with one of those, and a Orion 120 ST, or it was a 102 ST. It was a big, giant aluminum tube, real heavy. It's like an F5 scope. Great.
Big Newtonian telescope.
No, it was a refractor. It was a doublet.
Okay.
It was really great. Great for the moons, deep sky objects, and that's why he recommended it to me, and he gave me one. And then I asked him what type of eyepieces should I start out with. He said, well, since you're young and your eyes are still good, but you're a beginner and you're saving money, start out with the 52-degree series. Doesn't matter if it's a kit from Amazon or, again, Explore Scientific or anybody's. If you start out with a 52-degree series, you won't be disappointed because it gives you the best views and it's the best bang for your buck.
Right, not expensive.
And it's not going to
break the bank.
It's not going to have you killed by your wife.
Right. Although it did come later.
It did come later.
Yes.
It still sometimes still happens. So I started using the Orion and the AVX and started learning the sky visually. I didn't do it for very long. I maybe gave it 6 months. And then I said, no, I don't want to do this because the sky is huge. If you don't think how big the sky actually is and how many objects there are.
There's a quote for you. The sky is huge.
That's big. It's very big.
Big.
There's a total of 88 constellations. Now, I don't know if that's a counting of the southern hemisphere as well.
It does.
So how many do you see in the northern hemisphere then?
60-something.
So 60 constellations that you're looking throughout the whole night. You know how many objects that is?
10 or 12.
Or more.
Maybe more.
There's a ton of stuff.
The hard part is
learning where it is
knowing what to look at. Not even
even with a go-to mount, you can put that thing and it gives you a Messier whatever. Well, what the heck's a Messier object?
Well, it should tell you what it is.
Well, not in this.
Explore Stars does.
Explore Stars does,
mm-hmm.
but not the mount that I had at the current time.
Right.
it did not give you much of a database. It gave you an RA and a deck coordinate. That's all it gave you. It didn't give you any what it is or anything.
So is that a current comment from Tariq?
Yeah, that one is. I bought many books. I didn't read them yet. I don't know when I will read them. Now I'm scared that if I read them, that I will find out that I've learned that already without books.
Tariq, I'll tell you right now, read them. I go back and read books I've read before, and I always learn something new.
You always do.
You know, it's like I'll read the the PMC8 system manual.
Yeah.
You know, just read it again, just to think about what I'm working on and what I'm doing.
Mm-hmm.
To read, just read it. Don't be afraid of. If you learn something you've already learned, that's just reinforcement.
It is.
Right?
You're just soaking it in.
You're soaking it in. Right. Okay. So
where were we at?
You had stubbed your toe, and were tired of.
That's right.
The sky was too big of a place for your meager soul, and so you decided to just start. You were going to say, start taking pictures.
Start taking pictures.
Right.
So I had a Nikon D3200, which is a basic kit camera or DSLR.
Right.
So then learning visual, it was tough for me. Because you're learning focal lengths, you're learning field of views, you're learning apertures, you're learning not really f-stops, but you're learning field of views to a degree.
And you're suffering from Bortle 6 guys.
5, 6, yeah.
Yeah.
So I can see stuff
that a lot of people can't.
A lot of people can't. I can see galaxies, M101, M51.
But you didn't know where to look.
Didn't know where to look. Even I can have a controller to tell me. I didn't know what diddly squat a polar alignment was either at that time. Doing visual. Didn't have a clue. Pointed it north, got the latitude, but I was probably off 4 or 5 degrees.
Left or right?
Probably to the left.
Yeah, but one way. I mean,
one way or another, I was off, and it would never slew to where I was wanting to go.
Which is why my method of
your broom method.
Yeah, the broom method.
The broom method always works, or the compass.
The compass works.
The compass works. We actually did it in Fort Worth.
And I've told that story. Let's show you a version of that.
Of the Fort Worth one?
Yeah.
So me and Kent had to go to Fort Worth, Texas a month ago. And some people were wanting, and it was basically we were out there just promoting our stuff. And we were
at a camera shop.
In a camera shop. And I figured, well, I'm going to throw an 80 millimeter on an IXOS 100 with a DSLR on it. How do you polar align?
It only had 2 counterweights on it.
It only had 2 counterweights.
It needs 3 to balance. We only had 2. Tough. We just did it, and guess what? It worked.
So he was behind me, and I was pointing I had the front leg pointing north, and he was telling me to go left or right, and I had to make
clockwise, counterclockwise.
Yeah, clockwise, counterclockwise. And once I got it in frame,
once I said, okay, we're done, I went off to do something else.
Yeah, you went off to do something. I slewed to the sun. Yep.
Is it your version or Tyler's version you're wanting him to tell?
Well, it's hard because I know what my version is, and his is wrong. Go ahead, finish up.
I thought it was a different side of the story.
Finish up your version.
His is the correct version.
Paul, you make your good point, but mine's right.
So I flew to the sun with the camera on, and I could see the sun, and I just let it sit there because he always says, let it sit, see if it drifts. Mm-hmm. And it didn't drift. Didn't move at all. Now, I noticed that it wasn't dead center of the frame, but I didn't care. It was a 80 millimeter scope.
But it was the full disc of the sun.
Full disc of the sun.
Well within the image of the field of the camera.
Correct.
So it wasn't like it was like.
It wasn't half off the sun.
Half off. It was
full disc, see it, but it wasn't just in the corner of the view.
Okay, so let's let it drift to let the motors catch up.
Let it sit there for 2 or 3 minutes, let it catch up. And then I barely even move it. I don't even touch it.
I came out and said, how close was it?
It's right there.
He said, I saw it. I said, did you have to adjust it left, right, up, down? No.
And we let it sit for 6.5 hours.
Yeah. Well over 5 hours.
Yeah. It never moved.
Towards the end, it started drifting off in declination just a little bit.
Oh, because of the Meridian Flip.
We'd had to do a manual. Yeah. And to do a Meridian Flip with, and this was on an IEXOS 100.
Yep.
And with the PM8 system, either the Exos 2 GT with PM8 or the IEXOS 100, a Meridian Flip is real simple to do.
It is.
A Meridian Flip is what happens when the telescope gets across the sky. It goes past the meridian. And so to get it back in balance and everything, you've got to flip the meridian. So it's real simple. If you did a go-to like the sun, after it gets past the meridian, it's real simple. You just go and do another go-to to the sun. It right knows it's past the meridian, so it flips everything around and does the flip for you. And we were almost right back on the sun, went bink, bink, bink. And that was it for another 3 hours. I mean, it was really impressive how accurate of a polar alignment we got.
With a magnet.
With a magnet. And me holding the compass up like this with one eye, looking at the compass angle, and telling Tyler to move it, twist it right back a little bit. That's it. Oh, yep, right there. Literally took a minute.
Yeah.
And we got lucky. Perfect polar alignment.
Skill.
Yeah, luck. There's still luck involved in that.
No,
Yeah, absolutely.
That's
So,
years of
but
doing
you didn't
it.
know how to do that.
I didn't know how to polar align.
Yeah.
No, I didn't even know what a polar alignment was. I didn't delve deep enough into cloudy nights.
So why didn't you just walk away right there?
I didn't want to. I don't have that personality to get up and walk away.
So
I don't.
You felt like you could brute force it.
Yes.
No offense to
Yeah.
muscles. You felt. You really felt like you. By golly, I can't.
I wasn't going to stop
do
until
this.
I got it. I'm not the most smartest person in the world, and I'm not the most dumbest person in the world. And for me to understand things, I have to read a lot.
And so you just started.
Giggle and giggle.
Yeah. And Tyler and reading go together like peanut butter and sand.
Yes. I don't read. I'm not a reader. I learn by trial by error.
Yeah.
I read some of the information if I need to read it, and then I was like, all right, I read it. I'm going to go do it. And then I'm just going to trial by error and be done.
That's how he coaches baseball too, but different story.
That's why we won 3 championships.
That was brute force of the boys.
That's right.
They hit the ball farther than the other team did.
That's right.
Yeah, that's exactly right.
So once I learned how to polar align, then the actual go-to accuracy improved dramatically.
Right.
100% dramatically. So I'm slewing to objects, looking at it.
Weird.
And
That
no, it's
polar
weird.
alignment made
just
things
fixes
work better.
everything better.
Wow.
Oh no, it still worked,
Yeah.
just better.
Yeah, just better.
Just better. So the porting accuracy was a lot better. But I was with the 120. I can't remember the field of view that I was able to get with it without. I think the focal length was around 600. So it gave me a nice field of view. I can get most objects, clusters, most Messier objects.
I mean, North American Nebula is not going to fit because it's so big.
You can't see it.
Yeah, you can't see it.
You can't see it. That's
yeah.
the problem. You see the star formations, but
Right,
you can't see the nebula.
It's not like Orion M42 where you can see it.
Yeah.
There's lots of nebulas that you might be able to see under. You can see under really dark skies. Yeah. You can. That's how people found them, was under really dark skies.
Yeah.
So
where I'm at, you can't see them.
Yeah. Right.
I mean, because you were out a while ago. We were using the bino viewers, I believe, and trying to find M101.
Yes, to see what it looked like.
To see what it looked like, we could find.
It was maybe there, but it was so
crappy weather and sky and seeing.
Right.
And that's the other thing is I didn't know how seeing played or involved in anything.
Because one night you'd go out and get great pictures, and you got the next night and you couldn't get diddly, and you didn't understand that the sky was different that night. The air was.
I had no idea why the stars twinkled. I just thought it was normal. Didn't think anything of it.
And you didn't have a correlation. And like last night, I didn't notice the stars weren't twinkling, but now last night was a really steady night, and maybe they weren't twinkling as much.
Yeah.
But tonight they're twinkling, and your pictures are cruddy.
Yeah.
Because you didn't just telescope or the camera, or you did something wrong. Yeah. No idea that the sky was fighting you tooth and nail.
Yep.
Yeah.
So again, I go back to the forums, try to figure out, because I've taken pictures on the back of a DSLR. Still don't know what processing is. Still don't know what stacking is.
Hey, there's Cesar. Cesar Bro. Hello, Cesar.
Hey, Cesar. Don't know any of that stuff. I'm just taking pictures just to see what I can get. I literally slew to an object. Oh, okay, take a picture. Take a 30-second exposure.
So you still hadn't started stacking or any what you consider to be some modern astrophotography.
I didn't even know what stacking was.
Yeah.
Didn't have a clue.
So how many years ago are we now? After you started, after you got your telescope for the kid and he didn't use it, and you got your first picture, how much? What time frame are we talking now?
2 or 3 months after.
So we're still talking
We're still
7
within a
years
year.
ago?
Yeah, we're still within
7
a year.
years ago?
Yeah,
Okay.
we're still within a year.
Okay.
So then once I figured out that it's like, oh, doing some more digging on the forums, you learn that, oh, you can actually stack pictures. Did not know that. You can stack pictures. So now I have a whole bunch of pictures that I try to stack, and I'm like, okay, how do I stack it? Well, there's got to be software or something out there. So it's, again, you have to Google or go to forums to figure it out. Nowadays, you can literally post it on social media and someone will just give you the answer.
Yeah.
It kind of chaps me a little bit.
It's easy. The reality is, Tyler, astrophotography is easier and easier and easier than it was for me. When I tried to do it with film, and you had to take it to, and you had to get it processed. Luckily, I had a good process black and white film, and still struggled. If you're trying to shoot in color, you know, Scott tells the story of trying to guide for like an hour.
Yeah.
Looking at an eyepiece with a left round, with a reticle eyepiece that has like a crosshair, like a pound sign or a hashtag.
Yeah.
And you real high power, and you keep the star in the center. And when you see it drifting, you hit the left button or the up button to get it centered back up.
You get centered back up.
Trying to get a 30-minute or an hour exposure.
The problem is, if you do that during an exposure, you could be messing up the whole image.
But you had to. That was the only way to guide.
I know.
That's the only way you could guide. Yeah. But it was the precursor of people finally thought, well, I can figure out how to put a CCD camera on a CMOS camera, and maybe I could keep it on the same pixel. It was the same exact thing. That's what a guide camera does.
Theoretically, pixel.
It's just it's on one little spot, and when it starts moving off, it goes left button, up button, up button, up button, and just keeps doing it until it keeps it on that spot.
Yeah.
It's the same thing.
Same concept.
It's just digital, not analog, with Scott looking through an eyepiece for an
hour.
hour.
That would have been fun to see.
Oh, boy. So Sarbrolo says, my interest is in trying some pictures with cell phone and some planets and planet cam sensible DSO, deep sea objects. He's also going to set up his
IXOS 100 with a Nat Geo 114.
F4.36.
38.
Oh, 38, yeah. Numbers. Yeah. Almost like letters and words.
They are.
Yeah, so that's going to be interesting to see.
It'd be interesting to see the cell phone.
I think it'll be interesting to see what he gets with the Nat Geo 114 f4.38 telescope.
Yeah.
You know, what he
trying to get with a cell phone and some planetary cameras.
Because that National Geographic 114 is not an expensive telescope.
No, gosh, no.
You know, and also what he gets with his cell phone. So
that and the planetary camera, because those sensors are small.
Oh yeah, little small sensors. So
you get a small sensor, you're increasing the field. Well, you're not increasing.
You're decreasing the field of view.
Decreasing the field of view tremendously, so it can focus just on that one little speck.
Yeah. Hey,
Pekka.
Hey, Pekka. How are you, sir? Glad to see you with us.
Oh, it's okay, Pekka. We're still
rambling on. We got another 34 minutes of ramble.
I can think of something.
Yeah, we can talk. So, okay, but you're still 6 months into this.
I'm still 6 months in, 7 years ago, and I'm just now figuring out their stacking capabilities. Mm-hmm. So, obviously, I picked Deep Sky Stacker because, again, Google. Mm-hmm. Astrophotography stacking software is just mainly thing what you Google, and the first thing that popped up at that time was Deep Sky Stacker. So once I get that all downloaded and all that stuff, I throw all my images in. Mm-hmm. It kicks it out immediately.
It says no.
It's like, no, can't do it.
Reject.
Darks, flats, biases. No clue what those were.
Yeah.
Didn't have a clue. Granted, Deep Sky
So you just took a bunch of pictures of...
A bunch of raw images from the camera.
Of what? Do you remember? Like M42 or just a galaxy or something?
I think it was maybe just a mixture of galaxies, M42, but it wasn't like 60 or 70.
But you tried to stack a bunch of different objects together? Really? You didn't know.
No.
So you took like M42 and a couple of galaxies and some
star clusters
and dumped them all in together, and Deep Sky Stacker went,
nope,
reject. Okay.
So once I learned obviously all the light frames had to match. And then you had to figure out
for light frames. If you don't know what light frames are your actual exposures of the object you're trying to get. Right.
Yep.
Oh, we got Mike Wiesner with us. He's twisting Cesar Brolo's arm to come from South America
I'll be
to
giving
the
it, ooh.
Arizona Dark Sky Star
I'll be
Party
giving
in
a cell phone
September.
talk.
Yeah,
Cell
and
phone
so
talk.
if y'all are wanting to come, it's going to be a great time. It's in Oracle, Arizona, September 21 through 24.
Mhm.
You saw Scott talking about it at the top of the show. We'll probably run that again here at the close of the show as well.
Yeah.
So anyway, all right, so back to
So light frames. So like Kent said, light frames are just whatever you're imaging, just constant exposure.
so you're shooting what exposures? 30 seconds a minute.
30 seconds, 100 at a time.
Okay.
So once I got my light frames, and then I did the process all over again with Deep Sky Stacker, I dumped all the raw frames in, kicked it out again immediately.
Because
It didn't have any light or flats, darks, or biases.
doesn't have to, does it?
Yes, it does.
Has to.
It doesn't have to, but it's recommended. Highly,
Okay.
highly
So
recommended.
so it could have stacked them up, but you didn't. At this point, you didn't have to know how to make it, right?
Yeah. So once I try to do things, I try to do it right the first time. That way I can build a repeatable pattern and keep going and going and
Right.
going. Question. Guys, older SCTs have the kind of amazing good optics that I've blown away. The original EPs were better than any of my high-end EPs, and they're from mid-70s but made in Japan. Well, you said the key word, semi-sentence, made in Japan. Japan's optics...
Today's coatings and better
the
glass
coatings are better.
The coatings and better glass,
Yeah.
and there's, I've got some eyepieces from the '80s, and they really don't compare to
Not like
modern
they used to,
eyepieces.
no.
I mean, they're just
there's two
it's
or
like-
three lenses in one, and now we have 7 to 8
or 9 or 10.
or 9 or 10 in an eyepiece.
And
I know that some of the old Russian, Soviet Union era camera lenses are really hot because they have this weird looking feel to them.
Feel or field?
Feel
when you say hot, you mean
Like stolen?
as in popular. Well, probably still
popular because they got that because that super retro look to them.
No.
Yeah.
No.
Cold War look.
Their glass was handmade and polished.
They're all handmade and polished.
Machine polished and final figure by hand.
No.
So,
There was no manufacturing process for those things. So some of the glass can be really, really good.
just like we know for a fact that there are some out there in the wild.
Yeah.
We guarantee our refractors to be a minimum of quarter wave. Which
We don't let them go until
we don't sell them
we
if
don't sell them.
if they don't come in at quarter wave or better. We don't sell them at all. I mean, we just don't sell them. We send them back. But I've looked at interferograms, and there are some 1/10 wave and 1/12 wave telescopes out there, which are high-end research grade telescopes that somebody got for the retail price of an FCD 100 127.
Lucky duck.
And we don't let people telescope shop and get the interferogram and say, I don't like this, and send it back. I don't like this one, because they're fishing for
Better.
the diamond in amongst the gravel. And there may be 250 telescopes in that batch, and there's two with 1/10 wave.
I'm not fishing.
Yeah. So anyway, for what everybody needs, 1/4 wave is perfectly fine.
Especially for astrophotography.
Yeah, but it sure feels. But it would be sort of just amazing to say I've got a 1/10 wave telescope. You don't ever use the resolution it can give you because you just don't have it.
I had a camera lens that was just super, and then it got stolen, and I got the same exact lens.
Except it wasn't the same exact lens. Yeah.
It wasn't as good.
Yeah. Yeah, Cesar Brolo agrees that the FCD 100 127 is amazing.
I
I have one.
I have an FCD 100 127. It's in the showroom. It's the showroom model. I take it out and use it. It is a beautiful telescope. It's carbon fiber version.
Yeah.
Okay, so anyway, you're still chugging along trying to figure out how to run DSS.
Yeah, just run DSS. I have to figure out how to take darks, biases, and flats. Now,
Okay,
what
talk
are
about
darks,
there you
biases,
go.
and flats?
Mhm.
Now, it's been a while since I've had to give this talk, so you may have to correct me if I'm wrong. Flats, if I remember correctly, are the same exposure of a light just taken a heck of a lot quicker. No, actually, it's the same exposure, but you have at the time I used an iPad.
Yeah, but
I white screened it.
A lot of people will take a T-shirt.
Yeah, T-shirt, throw it up at dawn or dusk, and point it straight up into the sky.
Or they'll use a fluorescent light and point it up in the sky.
Yeah,
but they're taking pictures of what you want to be a uniform
white, straight, even white,
right,
surface. Now, the purpose of a flat is to get rid of the dust bunnies,
because the dust bunnies will show up.
They will.
In that flat, and then you can subtract that information out and make the dust bunnies go away. All right.
The Caesar Brillo Kent, the new corrector is available for the 127.
The new field flattener is for F5 to F7 telescopes. Tyler's in the process of final testing. Hopes to finish that up maybe tonight if it stays clear.
Open.
He has not put it on a 127 yet.
Nope.
So we don't know. If you get the spacing correct, it's going to work acceptably. But we'll talk about field flatteners in a minute. Let's finish your story up. We'll come back.
So
let's remember field flatteners.
Darks are just the same exposure,
same temperature.
Well, it's a DSLR. You don't. That's the problem
of the inside of your lens cap.
Well, the problem is doesn't matter with the dark.
Typically, everybody just takes pictures of.
Yeah, but with a DSLR, we're going to jump to S's now. That does matter.
And how do you take those?
It's as fast as the camera can do it with the lens cap over it. Now, what that does is get rid of all the hot pixels.
Right. So every camera has a pixel that's burned out.
Yep.
And it shows up almost always, in my experience, as a red pixel.
Red, blue,
which they can look like a star.
Yeah.
Right? Because
really
one pixel, it looks like a star.
Yeah.
And so you want to subtract those out of your pictures as well.
Your final image.
So we're talking about some pretty complicated processing techniques.
Yeah, and I'm within a year and I'm already learning all this crazy stuff.
Most cameras don't have dead pixels.
A Nikon D3200 has hot pixels and dead pixels.
Any camera that's been around for a while is going to have a dead pixel.
Yeah. Yes. If it's pre-2000 or post-2000,
every camera
will have a dead pixel.
Every pixel array is going to have a dead pixel.
Especially when you're using a DSLR. Is if you're taking a 2-minute, 3-minute, or 5-minute exposure, you're going to see a hot pixel.
Sooner or later, you're going to see hot pixels.
Because DSLRs are not designed to...
They're not dead.
Yeah.
It's the opposite. Dead means they're not putting out any data.
Correct.
This means they're putting out data all the time.
Correct.
They're completely full.
Yeah.
If you think about a pixel like a bucket, once the bucket's full, all that light starts spilling over into others. Well, it's sort of the same thing, except that pixel just won't take any light. It's just always the color it's going to
correct
be.
And so, Norm is correct. The dark cell and DSLR are the same exposure / ISO as the lights.
Lights, right.
Okay. So it's been so long since I've used a DSLR, I couldn't not remember. So I get them all stacked in with the darks, flats, biases, and stack it all. And it's like, hey, I like it. Doesn't reject it. Yeah, it doesn't reject it. I believe it was a M13.
Okay.
Was it which
Hercules.
Is Hercules open, or it's a open cluster.
It's a globular cluster.
Globular cluster. And
very beautiful globular cluster in constellation Hercules, the keystone.
Now the thing is, on the screen it looked like a cup. It wasn't increased field of view. It wasn't like right up on top of it.
Okay.
So I literally saw like my screen like this. So I saw a cluster dead smack center of my screen. I was like, I got a cluster. Cool. Now what do I do?
Yeah.
Now what do I do? Because I didn't know what Photoshop. I heard of Photoshop. Didn't know what Photoshop was. Had no clue what PixInsight was. Never heard of GIMP. Any other type of post-processing software. I just took that image and said, okay, it looks great.
Yeah.
Because
you were happy.
Yeah, I was happy with it. I was like, I'm able to see something.
I did
that. I did that. And it took 7 to 8 months
Mm-hmm.
to get to that point. And then everything upgraded. I got a dedicated camera. Started out with a ZWO 294, which it's a ZWO product.
Did you start down the process of spending money to try and fix your way out of it?
Well,
to a certain point?
To a certain point, I knew I was going to need a dedicated camera to get rid of
You're
the thermal.
reading.
I was
You're reading. Told you enough that you wanted a dedicated astro
I'm going to
camera.
get a better picture quality. I'm going to need a dedicated camera.
And not a DSLR.
And not a DSLR.
Right.
Again, there's nothing wrong with DSLRs, but they'll only push you so far.
If you've got a DSLR, you can start doing astrophotography right now.
Yeah. I'm actually probably going to do it tonight when I'm doing my testing.
Just and let's show those next week.
Yeah.
Yeah.
You
can just put a DSLR on an Exos 100 or even just a tripod and take 30-second exposures and then look at it. The beautiful part about digital photography is you get instant feedback and make changes on the fly.
Yeah.
When it was filmed, you got feedback instantly after the film was processed in 2 or 3 days.
Right. 2 or 3 days later.
Yeah.
So if it's a big smudge, you're like, crap.
Exactly. If you got a focus or your exposure was too short or too long, oof. Right.
So I knew there was nothing wrong with my telescope.
So are we a year in now?
We're a little over a year now.
Okay.
Knew I had to get a dedicated camera.
So this is 2016?
Yeah. It's
2016.
Yeah.
Okay.
I won't. We're going to read questions now. Answered Norm Hughes's. If I knew, Tariq saying, if I knew that I will get into astro in the future, then I would never buy a DSLR, not even a medium format. But things happen. And then Tarek says, I hope I won't give up astrophotography also after a while. And then Mr. Norm Hughes, I love using my DSLR. They take great images. Dedicated cams are best as they're cool, and DSLRs just takes good images.
So I want to talk about, Tariq also says just now, but I'm really happy that when I started astrophotography, I didn't really get by.
I really did
get by a dedicated camera and nice mount from beginning and one high quality filter. You know, I think that the thing is, you know, our interest in hobbies change over time. You know, I used to go fishing every day off I had.
Mm-hmm.
I'd go trout fishing.
Nice.
You know, and don't do that. When I was in high school, in middle school, junior high school, man, we go backpacking a couple times a month or go canoeing. I mean, really spend a lot of time outdoors. But families come along, you know, things change, and you reach the point in astrophotography that you want to do something else. I have a friend, you know, that we've had on the show a couple of times, John Adler, and, you know, he's been a deep sky guy.
Yeah.
Bought and paid for deep sky. But he started doing some lunar, and now he started doing some solar, and he's finding new inspiration. And it's different. It's different processing.
It's a whole
different exposures. It becomes a whole new ballgame. And that's how he's sort of, I think, challenging himself to do more.
Because I have a buddy that's wanting to do a year-long cycle of solar imaging.
Yeah.
He'll literally go out
every day. Every clear day.
He will go out on his lunch break, take 30 minutes worth of imaging, go back in, do it again. Rinse and repeat for 365 days of the year.
Osmosis likes using the Mark 1R and Mark 1L visual all day or all night.
Night.
The Mark 1, if you've got dark skies, you know, it is the original astronomy
That's
tools.
what I'm hoping. If I get a chance to go to the Oracle thing.
You're going. Unless you don't.
I hope that the wildfires are contained.
Yep.
Because the last dark sky we went to was Kenton, Oklahoma, and it was still dealing with.
We got one night of okay viewing, and the second night
it was just okay. The clouds were rolled in still from the fires.
Smoke clouds rolled in.
Yeah. And I mean, you can still see stuff. You still see the Milky Way, but I want to see what it's like steady.
You want to see the glory.
I want to see the glory and all that she's worth.
Yeah.
That's what I want to see. Let's see. Tariq says, I just wanted to go from good to best, and then I decided I should at least start with something best and keep learning. That's the key. If you want to set yourself up for success, there's nothing wrong with having high goals and high standards, but don't be upset when you don't reach them.
Look, I think my guitar discussion works really well. You know, if you want to be a guitar virtuoso and play, you know, Stairway to Heaven better than anybody, or or play the 7-minute guitar solo off of Leonard Skinner's Freebird.
Oh gosh.
If you buy a guitar today, Tyler, do you play guitar?
Yeah, I have.
If you buy a guitar today,
I
can you play Freebird tonight?
No.
Nobody can do it.
Well,
maybe there's one out of a couple of millions.
There's probably those ones that are just super in tune that can hear it once and just immediately
figure it out. Right. But the average person takes years of practice to get to that point. And to be, if you want to be Jack Newton is a great astrophotographer.
Yep.
But he's been doing it since the 1970s. I mean, he was the first guy to take pictures of a lot of objects with CCD cameras. I mean, he literally invented before SBIG came out with their digital camera, he had the pre-production model and did things like take pictures of stars during the day and planets during the day, and nobody thought it could be done. And he did it. So, if you want to be that good, you got to pay your dues. Here's the cool part. You don't have to pay nearly the dues that he had to pay because you're using digital. And you have the benefit of everybody who's learned stuff as well. So, it's easier today than it ever was, and it's still hard.
It still is hard.
But you've got to just start doing it.
Especially with families.
Stick to it. Yeah?
My issue with now is I go to bed early. I do. I go to bed early.
I mean, you get here at 7:30.
I'm up at 5 a.m.
Yeah.
I go work out, and then I'm here by 7:30. I'm dropping the kids off at school, and come here, work 7:30 to 5, sometimes later. And too late.
Can't unring that bell.
Can't change that one. Then 5 o'clock rolls around. I go get the kids, go make dinner.
You got
by that time,
baseball practice or whatever.
7. My day's gone. But then I have to spend time with the family, hang out with them for a couple hours.
They can come out and hang out in the man cave.
At that point, if dinner's cooked and if it's going to be a clear night, I'm taking the telegizmo off the mount as I have a permanent pier system, and I'm throwing a telescope on. I'm letting it sit for about an hour and a half to 2.
Yeah.
Everything's loaded, everything's ready to go, and I just wait for dark, which is usually 9:30.
We got about 15 minutes, and we're only a year into your journey.
Yeah, maybe an episode. It's maybe episode.
So let's speed this up a little bit. All right. So I'll quit asking so many questions. Blow through this real quick.
Blow through it. So I end up with a 294, which is a one-shot color camera. So I had experience. I didn't want to get into monochrome. Heard the name or saw the word monochrome. Didn't have a clue what it is. Obviously, I know what monochrome is, but I didn't want to mess with all that stuff. Once I get the camera, then I notice, okay, I need to upgrade my telescope. And this is about the time that I find out about Explore Scientific. This was entering a year and a half at this point.
So Tyler's lived in Springdale, Arkansas, whole life?
Yeah, 36 years.
Yeah, whole life. And he didn't know that 3 miles from his house or 4 miles from his house is this. Yeah.
I did not know.
Yeah.
So then I wanted to upgrade my telescope. So I find out that I just Google telescope companies. First thing that pops up, I Explore Scientific. Literally 4 miles from the house. I'm like, what the crap? Did not know. And then I get introduced to Mike Hatch. Even though I've talked to Mike Hatch on the phone, it never dawned on me, hey, where are you guys located? Never dawned on me to ask. He hooks me up with an 80 millimeter. And an 80 millimeter is
it's the way to start.
It is the way to start.
It's not too big. It's not too small.
It's compact. It's travel friendly, especially with an AVX. It's travel friendly, and it's little bitty living space.
Yep.
So I started taking a bunch of images with that combination.
And that's the telescope I recommend.
That's the one I recommend.
Because
beginning.
And we've both had customers who wanted 127s or 152s, and it's like a small telescope lets you find success quickly and easily.
Exactly. And then I found out that I had to upgrade my mount. So I got another mount from Skywatcher. Had it for a while. I went through more mounts than anything. Then did that for about a year, that combination. Then I've upgraded the telescope. Upgraded to a 127 FCD 100.
You graduated.
I had a big graduation.
You mastered skills.
I mastered the little one. I knew polar alignment at that point. I knew what guiding was at that point, and knew I needed a bigger mount because if I was going with a 127, I had to have something with a bigger payload.
Right.
Because this is when I think everything nowadays is, well, it
So
is
are we
to me.
2017 now?
Yeah, 2017, 2018.
Okay.
That some manufacturers still went by the rules of half as far as weight capacity.
They don't tell you this.
They don't tell you. Well, it was on the Celestron. It was 15 pounds. Mount capacity was 30.
Right.
Astro is 15.
But there's no standard.
There is no standard.
And so you might see a telescope mount that has a capacity, it says its capacity is 28 pounds. And so you just assume you can put 28 pounds of telescope and cameras and everything on there. No, you can put, I'd always learned the rule of 60%. You can put 60% of that capacity is telescope and everything. And so you're looking at 17 pounds.
Yeah.
But on, yours, it may be 14 pounds.
Yeah.
So under the rule of 50%, you got 14 pounds. So you buy them out, you put it on, you find out you're overweight. There's all sorts of problems.
Then you hear all sorts of wonderful noises.
Explore Scientific doesn't do that, by the way.
Oh, it doesn't?
No, we sell.
I didn't get the PNC8 wasn't out at this time.
It was, but it was just coming out. It
Yeah.
was just coming out. We now tell you, we rate it at a capacity, and we say
20
X for camera and telescope and all gear.
for astrophotography.
For astrophotography.
28
Then,
pounds.
for an Exos 2 GT with PMC8, it's 28 pounds. 40 pounds for visual, right? Well, there's a video out there we need to find that's got 85 pounds on it. It's still working just like perfect. All right, so we're in 2018 now. You've got 127.
127, got a Skywatcher mount, using the ASI Air at this point, the first rendition. It was a great little thing. It lets you guide. It lets you plate solve. It let you, there was plate solving. Take images, do all that stuff. So use that for another couple of years. And then, so after a couple of years.
But while this is all going on, you're also working on your computer programming. You're learning how to align, how to find stuff. You're you're improving your techniques of manipulating your pictures.
And setup time.
Of stacking, quicker setup, quicker. You're understanding how all these pieces fit into this puzzle to make it work. And you make better, you go back and process data a year later, a year after you took pictures, you're better at processing data.
If you always take pictures, always keep that data.
Yeah, because
always
you can combine it.
Well, it's not even combine it, but if like you just said, if I took it 3 years ago and my processing skills have improved within those 3 years and I never touched that data, I can see what I can actually do with it.
So it's looking at the screen right now. Behind us is the Eagle Nebula.
Yeah.
Well, which the
it's M16. That was taken with by Mike with a 152.
Yeah, Mike.
I can't remember his last name.
I don't think it's on there.
Yeah, it is.
Is it? He took it with a 152 millimeter.
Mike Wills.
Mike Wills. That was a picture originally taken by the Hubble Space Telescope.
Yeah.
And people were blown away by it. 10 years, 15 years later, people are using amateur level telescopes to take picture quality that rivals the Hubble Space Telescope. That's the progress that's been made in astronomy. It's just amazing.
I wouldn't say the quality because from what the Hubble, granted the Hubble's a smaller field of view.
It's a space telescope with no atmosphere.
That's true.
Your ground-based stuff is taking pictures very comparable, favorably compared to the Hubble Space Telescope images. But anyway, so we're in 2018 now.
2018, 2019. Start talking with Mike more. Start messing with the 127 more. And then I get just a crazy hinkling. I want to do visual again. I wanted to pick up visual because learning the sky is very important.
You can do it. I've had people have been doing astrophotography for 5, 6, 7, 8 years.
Don't know where the sky is.
I'll say, well, what does it look like through your eyepiece?
What eyepiece?
I don't have an eyepiece. I'm like, huh?
I have a screen.
And I say, well, and they don't know where Vega is. They don't know where. They can't look up in the sky and tell you I'm looking right there.
Yeah.
And that's okay. That's them, right?
Yeah, it's just
they're doing them. There's nothing wrong with that. I mean, that's the hobby they get pleasure out of, is let the program called plate solve.
Yeah.
Plate solve. There's a term. That is alchemy, boys and girls. That is alchemy turning lead into gold.
That is math.
It's magic.
Math.
You take a picture of the sky, you dump the image into a program, the image makes a mathematical model of it, compares it to a sky chart, and goes, okay, I know where the camera's pointing,
but I'm not there.
And now I'm going to move the camera to what he wants me to move it to, and it's going to move the telescope to that spot, take another picture, and go, yeah, I'm where he wants me to go. And is this where you want to go?
That's the beauty thing about the ASI era. This was before Nina. I'm sure SGP and stuff was around, but I was using an iPad and a cell phone.
Yeah. Oh, look, Osmosis 007 is, he's in rural Iowa. 15 from my buddy's pasture, believe it's a Portal 2 sky. You can see the Milky Way. Well, yeah, from Portal 2, the Milky Way.
I hope so.
The Milky Way is going to be this big rip across the sky. It's going to be awesome.
And Pico says, I got my first scope for visual, a C8 orange from the mid-70s.
Yep.
And then Tariq's first scope was an ST80. Well, Ryan made some great scopes back when I was doing visual. The ST80s, I believe it was an ST102, ST120. Those are great, solid body scopes for visual.
So we got 6 minutes. We got to get through. Yeah, 5 years pushed into 6 minutes.
So I learned processing-ish. I still don't know how to process because I do more testing here than anything else. You learn how to troubleshoot real quick. You have to.
If you don't, it's a struggle.
It's a huge struggle.
And I think people don't approach it with a scientific, and I've taught you this.
Yeah.
And it's like,
it has to be a scientific method. You have to change one variable at one time.
And don't change anything else.
If you change the camera, the cables, the guide scope camera, the mount settings, and all that stuff,
you don't know what it was.
Too much.
You don't know what. You change one thing and test.
So it's kind of like
and write it down.
It's kind of like
write it down.
Testing for a field flattener.
Mm-hmm.
I got to figure out the backspacing because sometimes they're 55, sometimes they're plus or minus whatever.
Right.
So you got to add 1 millimeter spacing.
Sometimes we get people and they have a flare. Well, they just know it's the telescope.
It's not the telescope usually.
But how do we find out? Rotate everything except the telescope.
Yep.
And now we've proven that if it rotates, that's not the telescope.
Yeah.
It's coming from somewhere else. So now we rotate the camera.
Again, another 90 degrees.
And see if it rotated. If it didn't rotate, then we start narrowing down what's causing the situation.
Yep.
But you have to write it down. One of the guys on Mythbuster said difference between Adam Savage, I think. Yeah. The difference between science and play is when you do science, you write it down. And if you don't take careful records on exposure 1, 2, 3, 4, 6, you won't remember tomorrow what you did. You've got to write down on the first exposure I took. Mm-hmm. I took 5 exposures this way.
Yep.
And then I rotated this or did that 90, and you just change one variable at a time.
Yeah.
And you put it back to where it was and then change something else. And you're trying to narrow down what's causing it.
I think some of the issue is I'm going to use a fishing analogy because my dad always taught me patience.
Mm-hmm.
Nobody has it anymore.
No.
They want instant gratification.
They want that easy button.
Everybody wants an easy button.
Everybody wants to be able to push one button and be Jack Newton.
Yeah, that's what they want. Yeah. And if they have an issue, throw their hands up in the air.
And it's the telescope's fault. It's the computer's fault. It's the camera's fault.
No, I'm not saying that nobody can learn it. You just got to take the time to learn it.
You got to want to learn it.
You got to want to learn it. Just like any hobby. You got to want to do it. You can't just pick up something.
That's like saying, using the fishing.
Yeah.
I want to be on the pro bass circuit. So tonight,
I'm going to go get 15
I've bought
bass
a boat.
casters.
I've got a boat. I bought some rods and some lures. And I'm going to go out and I'm going to catch 8 5-pound fish.
Good luck. Good luck.
And you've never been fishing before.
I'm going to give you a good luck.
But we're going, I've heard this fish in Beaver Lake, and I'm going to go out there and I'm going to fish for them bass. And I'm going out there with my deep sea rod and a big number 06 hook.
Crap.
It's about that big, an 06
The
hook.
size of my hand.
And I'm going to go out there and I'm going to catch me a big old largemouth bass.
Yeah. Catfish too.
And it's not going to work. You know, you've got to do it. We're not doing this to say it's trying to scare you off.
No.
Manage your expectations.
I'm
Tyler's done it.
I'm setting your you're going to fail. That's part of it.
It's like baseball.
It's just
anything. Best hitter in baseball.
I guarantee you Paul failed a lot. He just won't admit it.
He won't admit it. The best hitters in baseball.
I didn't fail. I learned.
Aha.
The best hitters in baseball only bat 300.
Yeah.
Which means they strike out 7 out of 10 times.
Yep.
You just got to keep getting back up at the plate and try and take another picture.
That's true.
Yeah.
So fast forward till now. I have a pier set up in the backyard, which I need to do a video of everything.
By a pier, he's got a concrete pillar set in the ground with a mounting plate on the top.
36 inches deep, which is overkill where I'm at.
Better than underkill.
That is true. I'd rather go over.
Because you and I talked about it, and I said, it's better to go an extra foot than to go, gee, I wish I'd gone an extra 6 inches.
Once that concrete's poured, it's poured.
Yep.
And it's 16 inches around. And I belled it out at the bottom because you recommended doing a bell to give it more stability. And
lowers the center of gravity.
Lowers the center of gravity. So I had a tornado is not going to take that thing up.
Well, it might, but you won't. That'll be the least of your worries.
No, that thing won't move.
Speaking of which, his house almost got hit by a tornado earlier this year.
Yeah.
Missed you by a quarter
of a mile.
Yeah.
No.
Didn't destroy really destroy any houses. It damaged enough to where some are going to get torn down.
It damaged some buildings. It definitely damaged.
There were some warehouses, some metal buildings got
leveled.
Whammied.
Got leveled.
Yeah. So anyway.
So I got still got the 127 that I got from here. I got other scopes. Again, I need to do a series to just my stuff.
Yeah.
That's an hour long at least.
All right. So we're an hour in.
Yep.
That's how Tyler got started. You know,
it's a quick verse.
Yeah. A year every
2 minutes.
Yeah, 2 minutes maybe. So, the point of it is it's a journey. You got to start. You got to stick to it. Don't get down. Find success. I want you to find success early. That's why I preach. If you got a DSLR and a tripod, you can start Milky Way astrophotography tonight if it's clear.
Exactly.
Even under light polluted skies, you can go out and take ISO 1600 at f5.6 for 30 seconds and take a series of those and then use Deep Sky Stacker and stack them up?
Deep Sky Stacker is free.
Yeah.
So it's affordable. I mean, there's definitely other programs out there. I mean, you got Pix and Sight and everything else, but Deep Sky Stacker is just the easiest to understand.
The University of YouTube is
Sometimes
your
YouTube
savior.
doesn't have all the answers.
Yeah, but it's a great starting place.
It's a great starting place.
University of YouTube.
If you want to learn about the product and get an understanding of the product, YouTube will do it.
Yeah.
YouTube doesn't do much troubleshooting.
No, but by golly, if you want tutorials on how to use your stacking program or how to use PhD2, Push Here Dummy 2,
Push Here, ding dong,
which is a guiding program.
Yep.
There's all sorts of tutorials. These programs are very, very powerful.
Yes.
But to learn how to use
scary.
them. Yeah, I look at menus and what you do astrophotography and going,
my brain hurts.
How do you
Kent
buttons?
Just hands me the stuff. If it's
buttons,
astro, I get
you
it.
go do it.
But if there's a visual question, I go straight to Kent.
That's exactly right. And yeah. So anyway, Tyler, I've enjoyed hearing the story. It's
definitely more involved, but we only have an hour.
Yeah, well, we could talk about this for hours.
Oh God, yeah. 100%.
So we are going to start going live. My guess is probably next week. We'll have a channel that takes shows like this one and just keeps running them through.
Yeah.
We're going to do some commercials between, but it's going to be our programming go live 24/7, 365, using a new little device the size of an old cigar box. If you're old enough to
looks like a small humidor.
There's lots of people. I mean, cigar boxes were cool, man.
I know. I still have them.
I still got some cigar boxes, and they still make cigar boxes like they did. Really thick, heavy cardboard with.
Yeah, they do.
Do they? Yeah, you don't see them around.
The expensive cigars.
The expensive cigars, not like the Roy Tans that
not the
my
$20,
dad.
$10 ones. No.
Yeah, that from back in the 60s
those
and 70s.
are just cardboard.
Yeah, those are great boxes. Anyway, Dad still has some tools stored in some
good
of them.
baseball card holders too.
Oh yeah, there would be, wouldn't there? Yeah, so, anyway, all right. So for Explore Scientific, sir. Oh, and we're going to show you the trailer. Okay, Arizona Dark Sky Star Party, September 1 through September 24 at Oracle State Park, brought to you by the host, 21 through 24.
Okay.
2025, something like that.
Yep.
You can go onto our website, Explore Scientific, 21 through 25, explorescientific.com, Explore Alliance experiences, and boom, there you go, Arizona Dark Sky Star Party.
Come join us.
Come join us. You can stay at the Biosphere 2. It's going to cost you, I think, $512 for all the nights, which is like $120 a night or $100 a night.
We're going to be doing a whole lot of stuff.
We've got stuff going day and night. It's going to be exhausting.
Solar
during the day, bird watching. There's probably going to be some musical events, bird watching.
I'm gonna have to get into that
It's in the migration seasons in September, so you're going to be getting a lot of birds from the upper parts of North America going to be migrating through, which is a great time to pick up a bunch of birds you've never seen before. I'm planning on seeing a bunch of birds out west that I've never seen before. I'm looking forward to that.
Mm-hmm.
Scott's working on music and some food, and it's a festival, right? Going to be a good time. It's in Arizona. You can fly into Phoenix or Tucson, even closer. Tucson, Arizona is about an hour away, north of Tucson. You can fly in there. And look, if you've never done astronomy before, that's okay. If you have an interest in the night sky, this is going to be a place to come to really whet your interest. And it's got really dark skies. And I know Tyler is really looking forward to seeing, God willing, and the creek don't rise.
Oh, if it still rises.
Smokeless
skies.
Smoke-free, clear skies that offer astounding views of the sky.
Yeah.
So Arizona Dark Sky Star Party, the price is real affordable. You know, if you go anywhere and stay anywhere, you're going to spend that kind of money on hotels and stuff like that. So we're going to wrap it up tonight. Tomorrow's Thursday. I will be on at 1:30 on the social media, and then flip over on Amazon Live at 2:00. Doing On the Wing. We'll show you some pictures of birds and talk about how to get started or up your game in bird watching. And Tyler, you're going to take the Amazon broadcast on Friday because I've got a funeral to go to, and you get to do those. And you've got your show focus on astrophotography at 4:00 as well. Right? Yay, Tyler! Yay, Tyler! All right. So for everybody here at Explore Scientific, Paul Newton over in the control booth where he becomes an automaton and just goes to sleep.
Yeah, you are.
Yes, you are. You're plump and red.
Tomato.
You're plumping red because I made sure I got the contract.
Yes, I am red. I spent Saturday and Sunday out in the sun. And it's my last weekend of umpiring baseball for the summer because travel ball is over with. So I'm going to become less red for a while. To the fall, and then back into the baseball world again I go. Anyway, if you've ever wanted to umpire baseball, there's plenty of baseball to umpire and fewer umpires to do it. And here's what's awesome about it. You get yelled at by the parents who don't know the rules, and they just know you're wrong. And you get to get hit by baseballs, and you also get catchers 3/4 of the way through the game who walk up, start the inning, and say, "Hey, Blue, I really like you behind the plate. I like your strike zone, and man, I love talking to you." And then you go, yeah. And then right after that, some parent yells at you because
certain obscenities.
Because little
Timmy struck out on a bad pitch.
Little Timmy struck out on a belt shot, and for some reason, the umpire called it a strike.
I don't know why.
So, all right. Time to go. We got to get out of here. Have a great weekend. Have a great Wednesday night or Thursday, depending on where you are in the world. We'll see you on Thursday. Bye, everybody.
If you want to see amazing Milky Way views, you want to observe the stars, you want to hang out with astronomers, but you love art and you love music, you're going to want to come to the Arizona Dark Sky Star Party, September 21st to the 25th at Oracle State Park in Oracle, Arizona. It'll be an amazing event, and I know you're going to love it.